Video notes for lesson 15A. This is a unit on circles. We've gone through some definitions and area and circumference, and today we're going to talk about central angles. In circles, there are several different types of angles, and our focus today is going to be on the central angle. So by definition, a central angle is an angle with its vertex, remember that's the point of the angle, is at the center, hence the word central angle. And in this case, circle O, the vertex of angle POQ, that's going to be a central angle. The vertex is at the center, and the two sides, OP and OQ, are both radius, or plural, radii of the circle. So in my example here that I've outlined, angle POQ is a central angle. Remember, the middle letter here has to be the vertex or the point of the angle, which on central angles is going to be the center of the circle. So when we're talking about central angles, these right here, kind of around the center here, the sum of all of them is going to be 360 degrees. Okay, that should be a number that's familiar to you. Now, with central angles, we also have what's known as called an arc. Okay, and if I show you a highlight of this arc, okay, in this case, it's going to be from P to Q. And now an arc is just a part of a circle, okay, going around here. So when we find the measure of the arc, ARC, is formed by the endpoints of the central angle is equal to the central angle. All right, so the arc that goes with this angle, the central angle, the arc is arc PQ. Now often we would say PQ and there would be an arc over it. Okay, so that is going to equal the measurement of the central angle, which in this case is 85, so arc PQ is going to equal 85 degrees. Okay, so just like the central angles all right in here total 360, so do all of the arcs are also going to equal 360. So that would be all the way around the circle. These arcs, okay, and again, they're kind of a curved part of the circle, are going to total 360 degrees. Okay, and that's right there what I just said. Okay, so in this example, the measure of angle POQ, angle, that's the central angle, is 85 degrees. So arc PQ, and that's a weird arc, I know, but it should go like this, is going to equal 85 degrees. Now, those are called minor arcs, which you learned in Lesson 13, dealing with all the vocab. Minor arcs are those that are less than 180 degrees. When I have this, find the measure of arc, PRQ, I'm going to start at P, I'm going to go through R, and I'm going to keep on going till I stop at Q. PRQ. Let me clean this up a little bit so you can see which arc I'm talking about. So PRQ, that arc right there is going to be the whole thing, 360, minus the one I don't want, this piece right here between P and Q, this piece right here that I don't want. I'm going to subtract that, and that will tell me how many degrees arc PRQ is going to be, and that's going to be 275. Okay, so you'll notice this one is 275, and the little one here, the minor arc, is 85, and together they total 360. PRQ, using three letters like that, is called a major arc. So PQ is a minor, okay, and this one right here is a major. Okay, so just like anything, a minor is a smaller one. It is always indicated by the two letters, and a major is more than 180, more than just half, and that's indicated usually by three letters. And we'll see some more of those in our example. The measure of the arc formed by the endpoints of the diameter is equal to, so you can see here in my picture, the arc PRQ. Again, I started at P, I went through R, and I stopped at Q. Okay, that total is 180 degrees. Okay, so let's see what this looks like on a couple of examples here. So my first suggestion whenever you're dealing with arcs is to find all of the arcs first before you even start looking over here at what the problems are going to be. So I can see here they give me this angle A, let's call that OC, is 123 degrees. Now you can write it out here that AC, which is the arc that goes with it. Now how do I know? I follow the sides of the angle. Follow the sides of the angle. Those are the radius. Okay, and that angle and this arc are always going to be the same. Okay. Now, AB is a diameter. So AB, which is arc ACB, okay, this whole thing here is 180. So 180 minus 123 is going to give me 57. That means from B to C, that minor one is 57, and this one is half the circle, or 180. So if I would add these three together, right there, they should total 360 degrees. So once you've done that then the answers are really easy because you have just all the numbers. You're either going to have to do some adding or subtracting. So let's take a look. Now I've just written the word arc here, or typed the word arc, because the program I was using doesn't usually have a nice arc to it. But normally, like on a paper, you would see a little arc over each of these. Okay, it doesn't really make that much difference in what we're doing, but here we go. Arc AC, so from A to C, 2 letters, I'm going to go this short direction here, 123 degrees. BC, 57 degrees. See, I've done all the math. I just have to fill in the answers. Now, ACB, A through C, stop at B, that right there is 180 degrees. That's a half a circle, otherwise known as a semicircle. Now let's take a look. ABC. So this tells me where to start, what to go through, and where to end. So I'm going to start at A. I'm going to go through B, which means I'm going around this way first, and I'm going to stop at C. Okay, so let me get rid of some of this here so we can just look at that one individually. So this was 57 and 180. So this arc right here, ABC, is going to look like A through B and stop at C. That's the arc that we're looking at right here. So there's 2 ways that you can do it. You can add 180 plus 57. So arcs can be added just like angles can. 180 plus 57, or I can take the total, because I want all of the circle except 123. So I could take 360 minus the 123, or I can take 180 plus 57, and both answers will be the same, and in this case, 237 degrees. Now let's take a look at the next one. Arc CBA. So we're going to start at C, we're going to go through B, and we're going to end at A. So if you look, start at C, I got to go this way now because I need to go through B, and I'm going to stop at A. CBA, that's the same one that we just had, so 237 will also work. Now, both of those arcs are exactly the same. I'm putting this example in here to show you it doesn't matter which way those letters are going to go. And the last one, arc BAC. Arc BAC, let's get rid of this here. So we're going to start at B, we're going to go through A, so that means I got to go this way, and we're going to end at C. If I went this way, I'd hit C first, but I want to hit A first because that's next. So again, you can do arc addition. which would be the 180 plus the 123, because that would be this one, 180 plus the 123, or I want all of it except the 57. Okay, so I could take 180 plus 123, or I can take 360 minus 57. Okay, whichever way your brain thinks the best, totally up to you. So when I do so, I get 303 degrees. All right, let's stop there, and then we'll come back and do some more examples.